We're going to look at the rules for drawing and naming cyclic molecules, also known as cyclos. In our first example here, we have a structure that includes 5 carbons in a ring structure, and we are identifying that as our carbon backbone or base chain. So right here, we have our structure, 5 carbons, and we name it as cyclopentane. We have 2 side groups on the ring structure. Right here we have an ethyl and then a methyl up top. We are going to number it to give priority to the ethyl side group. There are a lot of rules that sometimes you'll need to look up to figure out which side group takes priority and gets the lowest number. We're going to keep things fairly simple in this course, and in this situation here with alkyl side groups, we're trying to go alphabetically. So we're going to give our ethyl side group a lower number than our methyl side group. So then, as we move up here, you can see that we're calling the ethyls carbon number 1, and then we're numbering up so that we can give the methyl a number 3, rather than if we had numbered in the other direction, it would have ended up being 1, 2, 3, 4. It would have been a 4. So we want to give this a 1 and this one a 3 to keep the numbering as low as possible. When we put this together then, we end up with a 1-ethyl, 3-methyl, cyclopentane. Now, I want to show you an error that students will frequently make. So you're going to see the error, and then I want you to just remember not to do this. So I'm going to highlight right here. Sometimes students will try to go outside of the ring, and they'll take their finger and follow along the molecule, trying to come up with the longest chain possible. Now, that strategy works in other circumstances, but definitely not with ring structures in combination with alkyl side groups. When you are choosing your longest continuous chain, you need to choose one or the other. So for instance, if this here had been a longer chain, perhaps we could have named the cyclo as an alkyl side group, but we're going to get into that a little bit lower down. For now, what you need to remember is that it's one or the other. In this situation here, we're choosing our cyclopentane. It's the longest chain with the greatest number of side groups. Cyclic molecules can also include double bonds, and with your molecular model set, I would encourage you to pause the video and construct this molecule so you can see what it looks like. When you put it together, you'll notice for numbering, there are a few things going on. We might have chosen to start our numbering up here, so up where the number 2 is currently, thinking that then we would go like this and around the molecule. Well, we're trying to give numbering priority as before to the double bond so that the double bond includes the lowest possible numbers. We're also striving to give our alkyl side groups the lowest numbers possible. So in this example here then, we are starting with this group right here, which is a butyl right here. A butyl side group, we're calling that number 1. And then if we number in this direction right here, we always do that, number through the double bond first. And then we're going to head over to our methyl group like that. So in that way, our butyl gets a low number. And of course, the priority part of the molecule, the double bond, gets the lowest possible number. When we put this together then, what we get is we get a cyclohexene, and the 1 in front indicates the position of the double bond. So we've got that 1 there telling us the double bond is between the 1 and 2 carbons in the ring structure. And then as before, what we're doing is we're positioning alphabetically. So we're putting the butyl out in front, not because it's at the number 1 position, but because B comes before M in the alphabet. We therefore end up with a 1-butyl, 4-methyl, 1-cyclohexene. Of course, you could nest that one as before, and you could have a cyclohex-1-ene. Now, the last example shown here is when we have a cyclic structure that's attached to a base chain. So in this situation, our cyclic structure only includes 3 carbons. It's a cyclopropyl. Instead of calling that our base chain cyclopropane with a butyl side group, the butyl or butane has 4 carbons. That's going to take priority. So this here then is going to be our base chain, butane. And then to indicate that the cyclopro is a side group, we want to make sure that we're putting YL as the suffix, and that tells the reader it's a side group, an alkyl side group, 2-cyclopropyl butane.